Alright, this is the second video for part 2 of your Unit 6 test review. So we're going to do the word problem first. It says a local pilot has offered to drop the game ball for the last football game from his airplane. I'm going to list out the terms as they tell us, because this is going to make a sequence. During the first second, the football falls 4.9 meters. During the second second, it falls 14.7 meters. During the third, 24.5 meters. And during the fourth, 34.3 meters. Is this pattern arithmetic, geometric, or neither? Well, it's probably not neither, or else we wouldn't be asking you these questions. So let's start with arithmetic. Alright, so we're starting with arithmetic. So in order to find the common difference for an arithmetic sequence, or just see if it's arithmetic, you're going to take the second term minus the first. So let's grab our calculators, and let's try 14.7 minus 4.9. And we get 9.8. Now, in order to check to see if it's arithmetic, we can see what is 14.7 plus 9.8. If I get 24.2, which is the next term, oh, I did something wrong, 9.5. All right, 14.7 plus 9.8 this time. I do get 24.5, which is the next term in the sequence. So that shows me that this is arithmetic. And to explain it, all you have to say is that it has a common difference of 9.8 meters. And you don't need to say a lot. Just tell me it has a common difference rather than a common ratio. If this pattern continues, how far will the football fall during the 15th second? Well, we're looking at an arithmetic sequence here, and I'm finding a term, the 15th term. So I'm going to use the a sub n formula. I'm going to find the 15th term in that pattern. So I'll take my first term, a sub 1, plus my common ratio times n minus 1. And all I have to do is type that straight into my calculator. So I have 4.9 plus 9.8 times 15 minus 1. And I get 142.1. The answer is incorrect on the answer page of your review, but this is the correct answer. I don't know what I did in my calculator the first time, but this is it. Alright, so in the 15th second, the football is going to fall 142.1 meters. Now, what's the total distance the football has fallen in those 15 seconds? Well, that uses the series formula, S sub n here. So I have all of the information I need. I'm finding the sum over those 15 seconds. N is 15. We're adding up 15 seconds worth. The first term is 4.9. And then the a sub n, that 15th second term, is 142.1. And all you have to do is type that into your calculator, and then you are all set here. So I have 15 over 2 times 4.9 plus 142.1. Enter. And that will be the sum of how far total the football falls during 15 seconds. So 1,102.5 meters. There you are. All right, number 6. Flip your page. We have a geometric series. Now that's going to be important. Make sure you notice that it says geometric series. That's this formula right here. Whose first term is 3 and whose common ratio is 4. Sums, so the sum here is 4,095. Find the number of terms, that's n, in the sum. So we're finding n, I'm using that sum formula. Let's stick our information in. S sub n is going to be this 4,095 equals, now I have the first term 3 times 1 minus r to the n over 1 minus r. Alright, what I'm going to do is simplify and solve that for n. Now I can tell that 1 minus 4 is negative 3 here. So in order to move that out of the denominator, I'm just going to multiply both sides by negative 3. So let's see. We have negative 3 times 4095 is that value. So that's what we have on the left right now. So negative 12285 equals 3 times 1 minus 4 to the n. Now I am eventually going to use a logarithm, our favorite, to get the n out of the exponent. But I cannot do that yet. I have to isolate the exponential here. In order to do that, I have to move the 3 and the 1. So I'm going to start by dividing by 3. Now you can trust me here, since we just multiplied by 3, that I would get negative 4095 equals 1 minus 4 to the n. Again, I still have not isolated the exponential. I still need to subtract 1 from both sides. I've seen a lot of mistakes on this step here. Subtract negative 4095 minus 1. It's going to be negative 4096. Make sure you're careful there. Equals negative 4 to the n. Now, before we move on, we talked about this in class, but you cannot take the log of a negative number. Okay? That's going to yell at you. So since I can't take the log of the negative, I have to remember that there's a little negative 1 right in front here, in front of the 4. I have to divide by that negative 1 first, and then I can take the log. That makes both numbers positive. Then I can throw a log at both sides. Okay, I divide by log of 4, and then I'll be able to get my answer. Since we are finding the term number n, our value should be an integer, a positive integer. Okay, if you don't get a positive integer, then you did something wrong. Here we go, n is 6. So you're adding up in this sequence 6 terms to get that sum. And that's it for number 6. All right, number 7, in 1995, the total box office revenue in U.S. movie theaters was about $5.02 billion. From 1995 to 2008, the total box office revenue increased by about 5.9% each year. What's the total box office revenue for the entire period? So that is going to be a sum, one of our estimates. Round your answer to the nearest $1 billion. All right, well, because we are doing percent increase, this is going to be a geometric sequence. I'm going to use this S sub n formula. So let's list out what we do know. The first year we're measuring is 1995, and we do know the revenue for 1995. That's $5.02 billion. You can leave it as 5.02. The common ratio, R, what you're multiplying by. Well, you're increasing by 5.9%. But remember, this is an exponential equation, and if we're doing percent increase, we have to do a 1 plus the percent. So it's going to be 1.059. Now, n is tricky here. You need to count the number of years from 1995 to 2008, including both. So we have 1995, 96, 97, 98, 99, 2000, 2001, 2, 3, 4, 5, 6, 7, 8. Okay, that's 14 years. Be careful with your counting of the n here. Now I have everything I need to be able to put into my sum. So I'm finding the sum of the box office revenues for all 14 years. Take my first term, 5.02. That's 1 minus my r value to the n over 1 minus r. And I'm going to very carefully type that in my calculator. It says here to round to the nearest whole $1 billion, so we'll do that. So let's see, I'm going to make a fraction. If you don't have that ability, that's totally fine. 5.02 is 1 minus 1.059. See, there we go, and that's about $105 billion. That's a lot of money that they get from watching movies. There you go. All right, last one here. Number 8. In a geometric sequence, we know the third term is 12 and the 8th term is 384. Find the sum of the first 10 terms. Okay, so what do we know? We know the third term is 12, 4, 5, 6, 7, and the 8th term is 384. Find the sum of the first 10. Well, in order to find the sum, which is going to be a geometric sum here, I need a common ratio. So I need to calculate that. So this is what I'm going to do. We've done this, I think, earlier in the packet, maybe in part 1. we need to count here. If I start at 12, I'm multiplying by r once, 2, 3, 4, 5 times. Now if I'm writing that out, that's 12 times r times itself 5 times. Now remember, the shorter way to write all that is to say I'm multiplying 12 by r to the 5th to get me to 384. And I'm going to solve that for r. So I'm going to start by taking 384 divided by 12, and I get 32. Okay, so I have r to the 5th is 32. And you should know what the 5th root of 32 is based on our last unit. Oops, that just looks sloppy. Let me rewrite it. You should know that that r is 2. If you don't, let me remind you where the 5th root is on your calculator. You will go to math, number 5, and then you can type in the 5th root of 32. Alright, so to finish this problem here, I know that r is 2, so now I can put everything I know into my sum formula, finding the sum for 10 terms. The first term, oh, I don't know the first term, I have to go backwards here. The first term, let's see. I'm going to go back 1, 2 blanks. I'm going to squeeze it in. And I know I'm multiplying by 2 every time here to go from term to term. To go left or backwards, I have to divide by 2. So 12 divided by 2 is 6. Divided by 2 is 3. So my first term is 3. 1 minus the common ratio to the n power over 1 minus r. And then you can type that into your calculator. Let's go 3 times 1 minus 2 to the 10th over 1 minus 2. And that is your sum, 3016. Alright, that is the end of part 2. If you want to look at the part 3 videos, go back to Canvas.